So I said this is not going to be nice. Well, after evaluating this, I'm going to write this in scientific notation. This is 5.127, I don't know, we'll round it 3 decimal places here, times 10 to the, now I'm just approximating this, okay? This is just an approximation, times 10 to the 13th. You can get that all in one solid fraction if you want, or evaluate however you want to do it. Anyway, but this is what you should come up with, 5.127 times 10 to the 13th. And what this means is, if you don't know scientific notation, this basically means we're going to move the decimal place 13 places to the right. But then again, there's a lot of other, I cut it off to 7 right here, but there's a lot of other digits after it. It's not just zeros. But anyway, that's a good approximation. So there you go. Let's move on to another one. So we have the integral from 0 to 2 of 1 over the square root of 2x plus 1 dx out here. We're going to let our u be the 2x plus 1, because when we take the derivative of this inside here, what do we get? We get 2, but so we could write a 2 and then a 1/2 outside. Alright, du is equal to 2 dx, and let's go ahead and take care of our limits here. So we're going to plug 2 in, so we have 2 times 2 plus 1, and that's going to be 5. And then we'll do our lower limit, calling that use of a, so that's 2 times 0 plus 1, and that's just 1. Alright, we do the substitution. Now remember, we don't have a 2 up here, so we're going to write a 2 in, and therefore we must put a 1/2 outside. So there's our 1/2. Go ahead and write our limits in. So from 1 to 5 we are going, and this becomes 1 over, and I'm going to go ahead and get this out of radical form and just write it as like this, u to the half, trying to save a step or two. We need to write this one more time before we actually take the integral of it. We have a half times, going from 1 to 5, of u to the negative a half, and ooh, I made a mistake here. That should be du. I'm sure someone saw that. Right, du, not dx. So this becomes 1 over 2 times u, adding 1 to the exponent gives us a half. Then we put the exponent down below, and we're going from 1 to 5. I start getting in a hurry and my handwriting starts getting worse. So we have a half, and then we have a half down here, so that's going to disappear. So I'm rewriting this one more time. So this is going to be a whole lot better than the last problem we did. And this becomes 5 raised to the half minus 1 raised to the half. Well, we started with radicals. We should end our problem probably with writing our answer in radical form, and then that just becomes 1. So there is the exact answer. We don't have to approximate on this problem here. There it is. So that's nice. That's nice. Well, I think this is going to conclude some examples in solving definite integrals using u substitution. All right. Definite because we have limits here.